So I'm going to talk a little bit about what TDE is, how it works under the covers, just so we've got kind of a baseline of knowledge. Okay, so first of all, from a licensing perspective, TDE is a product. It's an add-on product for the enterprise database specifically. So depending on your release, you've got some options. Tend to be in later. There's a TDE add-on product for the enterprise database. As of 11.5, there's a bundle called Advanced Edition Enterprise Database, which is the enterprise database plus all of the add-on products, including TDE. And in 12.6, a new product was added called OE Advanced Security. And there's a talk about that this week. So what is it? It's, as I mentioned, encryption at rest, symmetric encryption, so static keys. The data, when it's in memory, when it's in the buffer pool, is still unencrypted. So in that way, your applications don't know about the encryption, so it's transparent in that sense. You don't have to make any code changes to your application, whether it's ABL or SQL, they're still going to work. And the keys are stored in a new database file called the key store, that's dbname.ks in the database directory. The encryption is policy-based at the object level, and in the next slide I'll explain what I mean by object. These policies are stored in a new table called _sec_obj policy in the encryption policy area, which is an area you add to the database when you enable it. You're not allowed to read this table, so there are pro-util commands for that. And for each object, you can have a maximum of 2 policies, and they're called current and previous if there's a second one. And that permits you to rekey an object without having to decrypt it first. The unit of encryption is the database block. So an entire block gets encrypted except for the block header. So it's not file-based, it's not record or field-based. The single unit within an encrypted object is the block. The list of ciphers that you can use does vary by release. So if you're planning a deployment, check your release documentation. The default is AES 128. That's a good default. It's a good trade-off between security and performance, and you really shouldn't change that unless you have a compelling reason to do otherwise, like your security team tells you you have to. So what can you encrypt? Well, here's the list. Type 1 storage areas as a whole, objects that are in type 2 areas, so that is tables, indexes, or lobs, and that refers to the logical object as a whole, not a physical storage object. So for example, if you had table partitioning, you're not encrypting each partition individually, it's the entire table or the entire index. AI and BI encryption is enabled by default, although when that takes effect depends on how you implement, whether you do it online or offline. Your application data can also be in audit or CDC tables. You can encrypt those as well, although I'm not talking about that scenario today. And you can also optionally encrypt binary dump files. What you can't encrypt, well, the entire database in one shot, which is why I'm giving this talk. You can't encrypt type 2 storage areas, just the objects within them. You can't encrypt the control area or the schema area, but that's okay because you never have application data in your schema area, right? Just another good reason why you shouldn't. And if you do, you should be, table or index moving those out or doing a dump and load to get those out. You can't encrypt the encryption policy area for reasons that are hopefully obvious. You can't encrypt sequence values because they live in sequence blocks and they live in the schema area, but that's okay because really they're just numbers. They're not what I would consider sensitive data anyway. So when does encryption happen? It happens at the I/O level when blocks are read and written on disk. So if an encrypted block is read from a data extent into the buffer pool, that's when decryption happens. If a block in an object governed by an encryption policy is modified in the buffer pool, and then it's later written out to disk, it's then encrypted under the current policy. So there's a clear performance implication here. Your buffer pool needs to be tuned well, because the performance of your caching will determine how often you're going to pay that extra computational price of doing encryption or decryption. So if you can have more data memory resident and read and write less often, then your performance delta with using TDE will be less. And conversely, if you have poorly tuned application code, like you've got clients doing huge table scans or things like that and bringing lots and lots of data into the buffer pool, then that's going to hurt your performance. It's going to flush out other useful data, and so that's the kind of thing that you really want to avoid. So you might think I could just make a really big B and avoid this problem, but don't go crazy with it. Don't set such a big B that you're going to have other negative performance impacts, like you cause swapping in the OS, or you're extending your database shared memory across NUMA nodes. I'm not going to talk about NUMA today, but that's not something you want to do, as Tom demonstrated yesterday. So here's the pretty picture, at least as pretty as I can make it, of what I just said. So up top we've got, I can point. Up top we've got data in memory, and then we've got data on disk, as well as the key store, which is on disk. So when an encrypted block is read from an extent into the buffer pool, it's decrypted, and when it's written, it's encrypted. So I'll just talk a little bit about the encryption cache. It's similar in concept to the OM cache, which you may be familiar with, the object mapping cache, which is a cache of the storage object records. So the encryption cache is a collection of data from both the key store and the policy table. And there are two caches, primary and secondary. Access to the secondary cache is always latched with the EC latch. And that's where any online changes, new policies get written. And it's sized with the EC size parameter. It defaults to 1,000, and that the unit is policies. So with the default, you can fit up to 1,000 policies in the primary cache. The primary gets populated at database start, and 1,000 for the secondary as well. Don't be stingy with memory here. These are very small entries. It's not an exactly linear scale, but roughly for every one that you increase EC size, you're using another 215 bytes of shared memory. It's not a big deal. So my recommendation is calculate how many objects you want to encrypt. That is objects or areas. That's what I mean in this context by objects. Double that and make it a bit more. Because if you have policies for all of your objects and then you decide someday you need to rekey all your objects, well, that's creating that many new policies. Every time you change a key or you change a cipher, you're creating a new policy. The EC will expand if it needs to. It'll go up in increments of 1,000, but if it can't increase, if there isn't available excess shared memory, then the database will shut down. So that's why I say don't be stingy. You can increase it online, but only in 12.1 and later. And there's a screen in Promon, shared resources, which you may be familiar with. This is where we can see the OM cache as well. And at the bottom of the screen, we see the entries there for the EC primary and secondary. So when we encrypt data in a database, what actually gets encrypted? So this is a list of all of the block types and their block type numbers that you can find in a modern OpenEdge database. And so when we encrypt an object or an area, is it the entire thing that gets encrypted? No. It's actually just record and index blocks. So all of these other block types, there aren't as many of them typically as record or index blocks. But if you look at your ProStruct statistics or DB analysis, you might be surprised to find how many blocks there are in your database that aren't record or index blocks. So those are the only ones that are going to get encrypted in those objects. And even in a table or a lob, if you have record blocks that are completely unused, those will also not be encrypted. And that's just a performance optimization. There's no reason to encrypt them until they need to be because they have sensitive data in them. Just a quick word on Pro Backup. This is a screenshot of the documentation. Backup files are always encrypted. Not really. If you have data in objects that are not covered by an encryption policy, they're in plain text in the database, and they're going to be plain text in your Pro Backup file. In fairness to the documentation team, there is another place in the documents that makes a better description of this. It says, when you back up an encrypted database, the backup contains encrypted blocks. So again, whether it's in the database or in the backup file, the encryption is block-based, it's not file-based.